Here we are inside our malware analysis virtual machine again. So you've built your virtual machine, whether it be a Windows 7, Windows 10, or Linux virtual machine for malware analysis. And you can extract the files out to where you have them most convenient. You may find that you need to disable Windows Defender or create an exclusion folder for where you've unzipped the files, because you might find that Windows Defender in its automatic scanning will disable or eat up those files, as they will be triggered by the antivirus in Windows. Now you've got a few options with how to follow along or watch the malware analysis labs. If you're feeling confident, you can simply have a go and see how far you get in the deobfuscation that I present in various labs. If you want to, you can watch and perform along, stopping and starting the video, which whatever works for you. Or alternatively, you could watch the whole video and then have a go yourself at the end, running it through in its entirety. Whatever way works for you is fine, and as always, feel free to reach out if you have any questions about what's going on or what actions I'm performing. So let's load up the first sample that we're going to deal with, which is PowerShell from batch file. You can see that all these scripts are saved as a .txt file, which if you double click on them will open up in your text editor rather than executing. So it's not saved as a batch file to execute or PowerShell or JavaScript or anything like that. The first thing I like to do is open it up in a text file just to have a little browse to see what I'm dealing with. It also is important to see that it's not going to be a massive file that will crash your browser when you load it into CyberChef. We can already see that it's only 2 kilobytes, so we know that it's probably going to be fine. So we can see here that it's a very short file, and we can sort of make out the word PowerShell here, and we can see that there's a whole bunch of these carets. In fact, every second character is this caret here. So we've got a bit of an overview of what it looks like. We can simply pull that into pull that into CyberChef and start to have a look at how we're best going to deobfuscate it. Now, to start with, we might be wondering, well, this is a Windows batch file it's come from. What are these carets actually doing? So what we can do is, and it's the beauty of having a virtual machine, is maybe we could take this PowerShell exe with these carets, simply copy it, load up a Windows command prompt, and plug it in. Because we know that this is a batch file and that's the first thing that's going to be executed. And we can do a little test with something benign like this that will either break, or if we think it might just load PowerShell, then that's a step forward in our analysis that we can do. So we'll hit enter and we can see that it does load up a PowerShell prompt. So in actual fact, these carets here just appear to be for obfuscation rather than performing any sort of function. So we can probably safely just use the old find and replace. Got a simple string, and we'll find carets, and we'll just simply remove them because we know that it's not likely to do anything other than just have some sort of obfuscation, so that they're hoping maybe that the AV on the computer or any sort of other sort of analysis that's going on might be confused by the breaking of all these strings. So what we've got here is a blob of what appears to be encoded text, and at the end we're lucky enough to have a double equals indicating that it's likely base 64. Now what we can do then is simply use a regular expression and get the character set of base 64, which we know from earlier is A to Z 0 to 9 plus / equals, and then we'll get one that's 30 characters long to infinity. And you can see with our highlight matches on, it's grabbed all the text that we need. Now you may wonder, if you're sharp-eyed, why I bothered to put the capital A to Z when by default regular expression is case sensitive. So if I remove that A to Z, you see that because it's case insensitive, it's still going to grab all that data. If I turn case insensitive off, we've got the wrong character set and we have to have that A to Z back in. Now the reason I do that is purely muscle memory. I type this regular expression so often that I just do A to Z, capital A to Z, without really thinking about it. The other reason that I found is that CyberChef is slightly inconsistent. If I was to use a subsection, let's pull the subsection down here, you can see that the default selection is case sensitive when matching, whereas the default for regular expression is case insensitive, which is the polar opposite. So if I'd just typed without the capitals and decided to use a subsection, then it wouldn't be working. And I may spend wasted time trying to troubleshoot what I've done when it's simply a matter of not having the right character set in the first place. So I find that the extra half second it does take me to type that saves me some pain in the long run. In any case, we've successfully selected our via our regular expression, the encoded base 64, and we can go to list matches. From there, it's a case of simply converting it from base 64 here. And you can see that we've got kind of what looks like text here. In fact, we can make it out. We've got new, object, system, net, web client, and then download file, and everything there. And we can actually make out what's going on. It's a little bit hard to read, but we can see that we've reached some usable text. Now, why is it this sort of almost obfuscated here, but this text here with these full stops? And the truth is, it comes from the type of encoding that is used by PowerShell. So PowerShell uses UTF-16 little endian encoding, and this is what UTF-16 is represented as with this extra full stop. If we actually go to see what's happening at a lower level, and we can convert it to a hex dump, which will give the ASCII or UTF-16 representation and the hex bytes, we can see that we've got our data on the side and we've got our hex here. And you can see that interspersed between every character is this 00. It's not actually a full stop. It's full stop what CyberChef uses to represent a character that it can't print the actual text for. So if we were to do a find replace for full stop, we wouldn't actually remove this data here. It's the type of encoding that's being used. So how can we fix this to make it easier to cut and paste data out or to present in a report? Well, we'll simply use the decode text function, which allows us to translate text from a whole bunch of different types of encoding to readable format. So we want to select what the format is, which is UTF-16 little endian, and we can see that immediately removes those hex 00s to a readable format. And again, if we want to be sure, we can turn it into a hex dump to have a look. And we can see that those zeros in hex have been removed, and we're left with what is a normal looking readable script. So here we are, we're at the end of our deobfuscation for this. We can see new object system web client, download file, which is a good indicator that it's going to look at this URL here. We've got a file name, this hex file name .exe start process. So, and then it's pointing at this environment variable app data with this file name. And then you can see IEX for that invoke expression again, another download string, and another here an IP address with a file after it, and then exit. So we've got three key pieces of what I call tactical intelligence or indicators of compromise. We've got our first URL, we've got our app data location with our executable file, and we've got our second IP address file combination here. So we can pull these out of our script that we've deobfuscated and look at other endpoint logs or network telemetry to see whether other endpoints in our network have maybe accessed either of these remote locations, or whether anywhere on our system, especially in this environment app data folder, has this executable file, or we can look at forensic artifacts on the system to see whether this file has indeed executed. So that's our Windows batch file with PowerShell base64 encoding inside. The key points are that we want to make sure that we select all our data via regular expression, which keeps everything into one recipe. We could now save this recipe and pass it on to someone else for them to use in one fell swoop without having to tell them to cut and paste the base 64 out, put it into CyberChef and decode it, and go back and forth, which removes the potential for user error. We've also used the decode text function to convert it from the PowerShell encoding of UTF-16 to a readable format that we can then pull our indicators of compromise out.